Good morning, children. In this class, let us learn about section formula from chapter 7. What is section formula? Before going to learn about section formula, let us recall similarity condition. Already you people learned that similarity condition in 7th class. Congruence property of triangles and similarity of triangles. When we say two triangles or two objects, two closed geometrical figures are congruent. When we will say two geometrical figures are similar. Let us take a similarity condition. Suppose we have two triangles. The two triangles are similar. When we say that two triangles are similar, first of all, when we say the two objects are similar, the two objects are similar if and only if they have a same shape and different in sizes. That is the old one. That is the general issue of the similarity. But mathematically, how do we express similarity of two objects? Suppose there are two closed objects, closed geometrical figures like squares or circles or triangles, whatever it may be, rectangle. So when we say that two objects or two closed geometrical figures are similar, suppose I have drawn squares. This is one square and one more square is this one. So these two are squares. They are having same shape. That's why this is a square, this is a square. But they are not congruent. They are said to be similar. Why? Because their sizes are in proportion. Their sizes are in proportion. Therefore, shapes are same and the sizes are in proportion. What is the mean of proportion? Suppose this is 2 centimeters units distance. 2 centimeters distance means, and this is 5 centimeters distance means. So there existing a ratio. What ratio? 2:5 ratio. So means whatever this measure is, corresponding measures we will call this side and this side, and these two sides are corresponding. These two sides are corresponding and these two sides are corresponding. So whatever the corresponding sides are maintaining some relation, same ratio. Means this is 2:5, these two sides also 2:5, and these two sides also 2:5, and these two sides also 2:5. Therefore, we can say these two squares are similar. Two squares are similar. What is the condition for the similarity of two geometrical figures? Two geometrical figures are said to be similar if and only if they have of a same size. Same shape and corresponding size are proportion. If two geometrical figures maintain these two conditions, then we can say that two geometrical figures are similar. So suppose if we take a right angle triangles. These two triangles are certain. Suppose this is A, B, C, and this is X, Y, Z. X, Y, Z. So these two triangles are similar if and only if whatever the corresponding sides ratio, that means AB, and this corresponding side is X, Y, and the corresponding side of BC is Y, Z. BC and YZ, and this one, that is AC corresponding side is XZ. AC corresponding side is XZ. So the corresponding sides ratios are equal. Then we can say this triangle, this right angle triangle ABC is similar to triangle XYZ. So these two triangles are similar if and only if the corresponding sides ratios are equal. If corresponding sides ratios are equal, then two triangles are similar. Understood? So here two triangles are similar. What condition we will get? We will get AB by XY. That means corresponding sides ratios are equal. If corresponding sides of two triangles are equal, then they are similar. So this is the thing you people learn in the 7th class. Now how can we use this relation or this concept in explanation of section formula. First of all, what is meant by section formula? Section formula, already we discussed the distance between 2 points in the coordinate system. If 2 points are x1 by 1 and x2 by 2, then the distance between them is root over x2 minus x1 whole square plus y2 minus y1 whole square. Suppose this is one point, let it be A, that is x1 by 1, and there is another point B, x2 by 2. x2 by 2. So these are the 2 points. That means they maintain some distance. They maintain some distance. Suppose there is a line of measure 6 centimeters. 6 centimeters, and there existing. I am dividing the 6 centimeters length of line segment into 2 parts such that point P, which is 2 centimeters, and this is automatically total measure 6 centimeters means AP is 2 centimeters means then PB automatically is 4 centimeters. So 2 centimeters plus 4 centimeters is the total length, which is 6 centimeters. So how can we say there is a point P is in between A and B such that AP is 2 centimeters and PB is 4 centimeters. Therefore, this measure and this measure maintaining some ratio, no? That means AP and PB. What is the ratio of AP and PB? That means 2 is to 4. 2 1 times, 2 2 times. That means 1 is to 2. So that means here AP is to PB is equal to 1 is to 2 means this point P is dividing the whole distance in some ratio. What is that ratio? 1 is to 2. Here happened 1 is to 2. In some cases this is 3 centimeters. 3 centimeters means what happened? This point P. So 1 and 1, 2 and 1 is to 1. 1 is to 1 means what is this point? This point acts as a midpoint. We all know already the midpoint formula. What is that midpoint formula? x1 plus x2 by 2, comma y1 plus y2 by 2. We know the point, how to find the midpoint of a line segment. But here the question is, if any point existed in between 2 points of a line segment, then how that point dividing the given ratio. So at that time, how do we find this point? How do we find the point which is dividing the given line segment in some particular ratio? Here 3 is to 3 means you know it is a midpoint. So midpoint formula x1 plus x2 by 2, y1 plus y2 by 2. But in specified conditions is given. Here what here 1 centimeter, 2 centimeters, 4 centimeters means we got the ratio 1 is to 2. Means if this point is dividing the given line segment in the ratio of 1 is to 2, how do we get this point P? If the point is dividing the line segment in other ratio like 3 is to 4 or whatever the ratio is given, how do we find the point which is dividing in some particular ratio? Suppose the point here I am taking a point. I am taking point P. Point P, let it be x comma y. X comma y. It is dividing that point P is dividing AB and PB in the ratio of m1 is to m2. m1 is to m2. So how can we? Here point P is x comma y. Point P x comma y. This point P dividing the given line segment of quarter pairs of point A x1 by 1, point B x2 by 2. Then in the ratio of m1 is to m2, then how can we find P? Here P is x comma y. Okay, before going to take this, what do you mean of x1 by 1? x1 is the distance from y axis and y1 is the distance from x axis. So that means if you draw like this, so you know it, this is the distance of x1 units, and here to here distance is y1 units. In the same way, like that. Suppose if I make parallel line. Suppose A, M, or so here we have two triangles formed. Two triangles. One is PQA is right angle triangle, BRP also right angle triangle. So how can we find this AQ? AQ means LM. What is LM? Here to here distance is x1 and here to here distance is x. Therefore, the distance LM is nothing but x minus x1. So this is x minus x1. In the same manner, here to here distance is x2 and here to here distance is x. So therefore, the measure is OM minus OM is nothing but MN. That means OM is x2 minus x. x2 minus x is the distance of PR. Now PQ. What is PQ? Here PM minus QM is nothing but PQ. Again I will repeat. PM minus QM is PQ. Therefore, PM is y units and QM is nothing but AN, that is y1. Therefore, this measure is y minus y1. This measure is y minus y1. In the same manner, this is y2. Total measure is y2 and this measure is y. y2 minus y is that BR measure. BR. Then how do we get the point P? How do we get the point P? Okay. Here, okay, I am writing. Here, triangle PQA is similar to triangle BRP. Therefore, what relation you will get? PA by BP is equal to PA by BP. Otherwise, you take the basis AQ by PR is equal to PQ by BR, which is equal to AP by PB. AP by PB. These two triangles are right angle triangles. This triangle is right angle here, here right angle. These two are corresponding, therefore these two are equal. Therefore, the two triangles are similar. As per the criteria, we can get this relation. The corresponding sides ratios are equal. Now substitute the values. What is AQ? AQ is x minus x1. By what is PR? PR is x2 minus x, which is nothing but next PQ. PQ means y minus y1. BR. What is BR? Here BR is y2 minus y. AB. Here AB is M1 and PB is M2. So from this is equal to this is equal to this, means these two are related as well as these two are also related. If we have taken these two relations, you will get x minus x1 by x2 minus x, which is equal to m1 by m2. Now take cross multiplication, so that you will get m2 into x minus x1, which is equal to m1 into x2 minus x. Now mx2 minus m2 x minus m2 x1 is equal to m1 x2 minus m1 x. Now make same thing, variables are same. So m2 x m1 x is nothing but plus m1 x is equal to m1 x2 minus m2 x1 means that is m2 x. Again I am writing here, this is x variable term, this is x variable term. Now this is m2 x minus m2 x1. The relation, that is m2x minus m2 x1 is equal to m1 x2 minus m1 x means I am bringing this liquid terms to this side and this liquid term that side. So I got the relation m2x plus m1x, which is equal to m1 x2 minus both that side plus m2. So here I have x as common, therefore I will get m2 plus m1, and this is equal to m1 x2 plus m2 x1. So from this I will get x is equal to m1 x2 plus m2 x1 by m1 plus m2, or m2 plus m1 is nothing but I am writing m1 plus m2. This is a x value. Now in the same way, how do we find to take this relation? What is the relation? Y minus y1 by y2 minus y is equal to m1 by m2. Under cross multiplication, we will get m2 into y minus y1, which is nothing but m1 into y2 minus y. Now this is m2y minus m2y1 is nothing but m1y2 minus m1y. Y negative terms make it to positive by interchanging. Therefore, I will get m2y plus m1y is equal to m1y2 plus m2y1. Here y is common, therefore I will get m2 plus m1 is a factor. Now I will get m1y2 plus m2y1. Therefore, y is nothing but m1y2 plus m2y1 by m1 plus m2. m1 plus m2. That means this is x and this is y. What is the x? m1 x2 plus m2 x1 by m1 plus m2. And here y is m1 y2 plus m2 y1 by m1 plus m2. What is this x and y? These are the x and y. So this is the x. X means what? This is the order pair. What is y? This is the order pair. So point P is nothing but m1 x2 plus m2 by m2 x1 by m1 plus m2 comma m1 y2 plus m2 y1 by m1 plus m2. So this is the point. This point is dividing the given points A and B in the ratio of m1 to m2. So this is called as a section formula. This is called as a section formula. What is section formula? Whatever the point is dividing in a different ratio for the line segment which are having two endpoints A and B of x1 y1 and x2 y2, then P is nothing but m1 x2 plus m2 x1 by m1 plus m2, m1 y2 plus m2 y1 by m1 plus m2 is the point. It is dividing the given line segment in a specified ratio. Here, whatever the point is in between A and B, that means the point is inside, interior of the line segment. What is that? A x1 y1, B x2 y2, and P is dividing internally. P is dividing internally. P is dividing that AB internally in the ratio of m1 and m2. Then the point is, we will write internally. The point P is dividing the AB line segment internally in the ratio of m1 is to m2. Then P is m1x2 plus m2x1 by m1 plus m2 and m1/2 plus m2/1 by m1 plus m2. So this is x coordinate and this is the y coordinate. This is the section formula. What is section formula? That is a point P is inside. In some cases what happens is it is AB line segment. It is AB line segment. Point becomes outside. Point is outside. Therefore you get the AP and BB. This is the ratio. Therefore that means this point P dividing the AB externally. AB external, that is m1 and m2 ratio. Here is m2 and here to here is m1. m1 is to m2 externally means then the point P, I am writing this is externally. If the point is dividing the line segment externally in the ratio of m1 to m2, then point P is m1 x2 minus m2 x1 by m1 plus m2 and m1/2 minus m2/1 by m1 minus m2. So this is the formula, section formula. If the point is dividing the given line segment externally, Let us take one example. There are 2 points, A order pair 5, 4, B order pair -4, 2. This line segment having some distance and there exists a point P is dividing, don't know this point P, it is dividing the line segment in the ratio of 2:3. Line segment, this point is dividing internally in the ratio of 2:3. So that means here see this point P, this is 5, 4 order pair, the first quadrant, and here second quadrant -4, 2. And this is a line segment, have some measurement. We can find the length of the measure by using distance formula. And there is a point P. This is dividing this line segment in the ratio of 2:3. Then how do we find this point? So here point P means x, y. This point is internally. Internally is means we will use the formula m1 x2 plus m2 x1 by m1 plus m2 and m1/2 plus m2/1 by m1 plus m2. So internally is dividing. Therefore how do we find the coordinates of that point? So here A is given, B is given, and this is m1 is 2 and m2 is 3. So by using section formula, we can find the coordinates of the point P. So x1 y1, x2 y2, x1 y1, x2 y2. So what is P? P is nothing but m1 x2 plus m2 x1 by m1 plus m2 and then m1/2 plus m2/1 by m1 plus m2. Or you have every values, that is x1 value, y1 value, x2 value, and m1 and m. Just substitute that. Just like that. So what is the m1? M1 is 1, m1 is 2, x2 is -4 plus m2 is 3 and x1 is 5. And m1 plus m2, that is 2 plus 3. Now m1 is 2 and y2 is 2 plus 3 into 4 by 2 plus 3. So this is 4 by, this is -8 and 15 by 5 and 4 plus 12 by 5. So that means -15 and 8 is 7 by 5 and this is 16 by 5. So this is the order pair and this is the point P. This is dividing this line segment in the ratio of 2:3. 2:3. This is a point which is dividing the AB internally. Therefore, we are using the plus sign. If it is externally means we will use negative sign to solve. That is the use of the section formula. Use of the section formula means in whatever the ratio is given, what is the point dividing the line segment in the given ratio. That is the use of the section formula.